Hello, sixth graders. This is Mr. Burns from the Boathouse, and today we're going to focus on engineering design failures. Why don't you go ahead and grab your science notebook out and open up to your table of contents. All right, we need to update your table of contents today, so we'll start with the date there, and if you want to put in 3-4-21. Our topic will be engineering design failures, and that will go on page 45. So if you want to update your table of contents with that now, and then when you finish that, you can open up your notebook to page 45, and we'll title and date it. So when you get to page 45, go ahead and write in engineering design failures, as well as the date 3-4-21. And a number the page 45. As a reminder to you, remember as we flip from slide to slide, anything that's highlighted in yellow, you want to copy into your science notebook. And if I'm moving too quickly for you and you can't keep up, don't forget to hit the pause button, finish your note taking, and then resume playing the video. All right, so engineering design failures. Well, first of all, there is no perfect design. Engineers are always trying to make their products better, and that's why we have iPhone 1 and iPhone 2 and iPhone 3 and iPhone 4 and so forth, because they're always trying to improve it. In the engineering design process, engineers build prototypes, test, and repeat testing until they get a design that works. Then engineers start all over again to try to improve on their design. Design failure. During the design process, failure can happen many times. For example, think about when you built the house out of cards last week. How many times did your house come tumbling down and you had to come up with a different design? Did you also know design failure can happen after a product goes to production and is used by the public? For example, Toyota vehicle recalls, toy recalls, baby equipment recalls, etc. You hear about them all the time. Think about if you've heard about any of these. All right, these are some pictures of examples of things that have happened after products went to the public to be able to purchase. So if we look at just a handful of these pictures, in the upper left-hand corner, the Toyota vehicle maker. Okay, one issue some Toyota cars had many, many years ago is that they had a sticky gas pedal. Well, what does that even mean? It means typically with the gas pedal in your car, when you push down on it, the car moves forward, and when you take your foot off the gas pedal, it slows down. Well, with a specific model of Toyota many years ago, you push down on the pedal, and then to go faster, and then when you took your foot off the pedal to slow down, it would stay there. It was like it was stuck, and the car would keep going even when you wanted to slow down. They called that the sticky gas pedal, and that's something that they had to fix. Or in the middle of the slide here, in the middle of the page there, you see those children's toys. Those can be choking hazards for little kids, because they put them in their mouth and they try to eat them or swallow them. So that could be an issue. Or in the lower left-hand corner down there, you see the crib with the baby, and it's not a real baby, it's just a doll. But some babies were able to roll over and kind of slide in between there like that, and you could see how that could be an issue. So they had to recall those and fix that, because that could be obviously a major problem. Or even in the upper right-hand corner, as they look at the laptop computer, with the early generations of the laptop computer, some of them used to overheat and start on fire. So as you look at these pictures, they're just examples of things that were tested and thought were safe and ready to go for the public, and then once they're out in public, they found some issues with them, and then they had to have recalls to try to fix them. Engineering disasters. Learning from past failures helps to prevent future mistakes. Engineers respond to a customer's need by building or creating something along a certain set of guidelines to perform a given function. That device, plan, or creation should perform its function without failing. Through analysis and the study of engineering disasters, modern engineering designers can learn what not to do and how to create designs with a greater resistance to failure. In other words, engineers try to learn from past mistakes so that it doesn't happen again. All right, sixth graders, next we're going to take a look at 11 different types of technology and the cause of the disaster that happened with these technology. So what I'm going to have you do is copy this T-chart onto page 45 of your notebook. And you want the T-chart to look very similar to what you see on the screen. So on the left-hand side there, we'll start with that first, and that's the name of the 11 different types of technology there. And I'm going to read them off fairly quickly, but in a moment you can always pause the video to get yourself caught up. But we're going to take a look at the New Orleans levee, the World Trade Center, Hindenburg incident, Kansas City Hyatt Regency, the Titanic disaster, Tacoma Narrows Bridge, Challenger accident, Apollo 13, 3 Mile Island, Chernobyl, and the I-35W bridge collapse. So we want to write all 11 of those types of technology down the left-hand side of your page, and then over to the right, we're going to title it Cause of Disaster and leave open space. And what we will do is we will fill this chart in together as we move through the next several slides and we look at these different types of technology. So at this point, I would probably pause the video and finish copying all this information into or onto page 45. And then when you're done, you can restart it and we'll move on. All right, now we're going to take a look at those 11 different types of technology, starting with the New Orleans levee. And as we do that, remember anything that you see highlighted in yellow needs to be copied into page 45 of your science notebook. So as you're looking at your notebook, you can see the New Orleans levee, and then to the right of it, you have a column that's open and it says cause of disaster. You want to copy the yellow highlighted information there. So we'll start with the New Orleans levee. So the levee in New Orleans failed on August 29th, 2005. The levee broke from high water levels due to Hurricane Katrina. Many thousands of people's lives were ruined in the New Orleans district. Again, make sure you copy that highlighted yellow bullet, which is the second bullet point there. Reasons the levee failed. Massive amounts of water built up behind the levee. After the pressure reached the levee's breaking point, all the water drained into the city of New Orleans. Okay, so as the water level built up and rose behind the levee, it applied so much pressure that it began to crack and then it broke. And that's when the water came in. Poor designs, workmanship, and bad politics all seemingly led to the failure. Next, we'll move on to the World Trade Center. When? This took place on September 11th, 2001. What happened? Planes crashed into the towers as an act of terrorism against the U.S. What failed? The structural supports of the building failed. Why? Plane collision, continuous fire and failed sprinkler system, progressive collapse. So when the planes flew into the U.S. Or into the World Trade Center, the structural supports that hold the building up failed. So when we use the term structural collapse, what we're talking about there is this. When the planes flew into the building, they obviously took out a big chunk of the building, and the floors above and below that above and below where that collision took place were weak, and they started to collapse. The structure that holds up the building was too weak to stand up, and the whole building started to collapse as a result of that, and that's a progressive collapse. Possible corrective actions, in other words, what could they do differently? Supports that do not allow progressive collapse, so a different design to the building so it doesn't fall straight down. More effective fireproofing material. Who is at fault? Terrorists. Engineers. Remember, there's no perfect design, but this did allow engineers to take a look at it, and I don't know that they can necessarily make a building that is plane proof, but it does allow them to look at it and say, what could we do differently so maybe there's less damage, or what can we do to try to improve the design of it. The Hindenburg Incident. The Hindenburg Incident occurred on May 6, 1937. The Zeppelin that flew from Europe across the Atlantic Ocean was known as the Titanic of the Air, and it's just basically because of how large the Hindenburg was. As the huge Zeppelin approached Lakehurst, New Jersey, the large aircraft burst into flames and went down in a burning heap of fire. The burning Zeppelin fell from the sky. It only killed 35 people, but injured many more. The biggest question of all was, how did this happen? After the incident occurred, it was determined that the new and improved exterior covering of the aircraft was very flammable. The slightest spark easily could have set the covering ablaze. Most people originally believed that the air inside the aircraft that kept the Zeppelin aloft was to blame. Some said that it was too rich in oxygen. However, this was not the case. It is believed that as the Zeppelin approached Lakehurst, static friction caused a spark that sent the aircraft crashing to the ground. So the issue with the Hindenburg was that the exterior covering, the outside of the Hindenburg, was extremely flammable. In other words, it could start on fire super easily, and static friction is the spark that started it on fire. Since then, all new materials undergo rigorous chemical property testing for strength and ignition point, the point when an object is able to light on fire. So from this failure or disaster, engineers learned to redesign them so that they are less flammable. Learning from this incident has enabled us to safely travel the skies using air and hydrogen mixtures. Due to the Hindenburg incident, engineers have learned that nothing can be overlooked. Okay, the next one is called the Kansas City Hyatt Regency Hotel. On July 17, 1981, during a dance contest, the second and fourth floor walkways collapsed. Walkways would be kind of like a hallway. So the second floor and the fourth floor walkways or hallways collapsed. 114 people were killed. Over 200 people were injured. Cause of failure. Well, there's three things that they found had the biggest impact on this. So under the cause of disaster part in your notebook, you want to write these three things down. First of all, the design change of the walkway. Okay, a single rod to a double rod changed loading on the joint. So they just used a different type of design, essentially, on the walkway, and that design did not work as well as previous ones. Number two, did not meet building codes. In other words, it needed to support more weight. The type of design that they had set up there did not support the amount of weight that was on the walkway. And lastly, number three, poor construction, which means they had improper welding and connections, inadequate building materials there. So there's really three things, that caused this failure, which was the design change of the walkway, it did not meet building codes, and poor construction. The serious flaws of the revised design were further compounded by the fact that both designs placed the boats directly in a welded joint between two facing sea channels, the weakest structural point in the box beams. Photographs of the wreckage showed excessive deformations of the cross section. So typically the welded part of a joint is the weakest area, and they placed bolts through that, which is not a good idea. They should have put the bolts in a non-welded spot, which would be stronger. The Missouri Board of Architects, professional engineers, and land surveyors convicted the engineers employed by Jack D. Gillum and associates who had signed off on the final drawings of gross negligence, misconduct, and unprofessional conduct in the practice of engineering. Moving on to the Titanic disaster. The Titanic, which has the reputation of unsinkable, sank April 15th, 1912 at 2 a.m. So this ship was so big and so enormous and that they thought it would be impossible for it to sink. The ship was equipped with all sorts of facilities and built using the latest technology. The ship lurched sideways when it hit and then kept bouncing back against the iceberg, leaving space ruptures in the steel plate below the waterline. So essentially the Titanic scraped up against the side of an iceberg, and that iceberg put holes or slashes into the Titanic, and those holes occurred underwater, underneath the bottom sides of the boat, which then caused it to start taking in water. The steel that was used to make the ship had amounts of phosphorus, oxygen, and sulfur, which caused the steel to become more brittle as it sailed through the cold Atlantic Ocean. It was considered the best steel of the time. However, it wouldn't be acceptable for constructing ships today. It is possible that whatever steel was used, the ship would have suffered the same damage. But today's ships use an even better form of steel. The ship could have avoided the ice. Improved navigation devices are used today to help prevent the same fate. The responsibility fell upon the captain. New training and guidelines for operating ships have now improved. Also, lifeboat regulations have been increased. Key parts to this disaster: brittle steel, lack of navigation, and not enough lifeboats all contributed to the Titanic disaster. The Tacoma Narrows Bridge. On November 7th, 1940, a horrifying experience changed the science of bridge design forever. The Tacoma Narrows Bridge was a suspension bridge that caught the wind rather than allowing it to pass through. The wind set up a standing wave in the bridge, resulting in a corkscrewing motion of the roadway. There are several accounts of drivers saying that the 2,800-foot center was more of a roller coaster than a bridge. The bridge was nicknamed Galloping Gertie. So essentially what happened here is that there was strong winds blowing towards the bridge. And typically winds pass right through bridges. They're designed to allow the wind to pass through and not have a huge impact on the bridge. That was not the case of what happened at the Tacoma Narrows Bridge incident. Instead, the wind got hung up on the bridge and caused the bridge to start moving in kind of a roller coaster type fashion until it completely collapsed. A 42-mile-per-hour windstorm led to the bridge's collapse. Before the end, the bridge's sides were reportedly 28 feet higher than the other. The only fatality was a dog. After this catastrophe, engineers began including aerodynamics into the art of bridge design. Engineers later reinforced bridges such as the Golden Gate and many other suspended bridges. Challenger accident. The Space Shuttle Challenger was destroyed on a mission in 1986. STS-51-L was the name of the mission, which the main objective was to deploy the Tracking Data Relay Satellite 2. All 7 crew members on board were killed, which consisted of 5 men and 2 women, one of which was a school teacher. The cause: 73 seconds after launch, the Challenger was destroyed because of an O-ring seal failure in the booster system. The O-ring became brittle and allowed a plume of flame to stream out of the SRB, which weakened the external fuel tanks. This led to the orbiter's rapid breakup under aerodynamic stresses. President Reagan appointed a special commission to investigate the accident called the Rogers Commission. The Rogers Commission concluded that the poor design of the O-ring and a lack of inspections led to this disaster. This led to better designs and tests for the O-rings. This was the 10th and last mission flown by the Challenger. There were no further manned flights until late 1988. Okay, so our next one is going to be Apollo 13. Apollo 13 launched on April 11th, 1970, and landed on April 17th, 1970. But in between, there was an explosion, and that took place on April 13th, 1970. Apollo 13 was the 3rd planned mission to the moon, where they were to explore the Fra Mauro formation. About 200,000 miles from the moon, while stirring the oxygen tanks, an explosion occurred in oxygen tank 2. The oxygen was stirred to stop stratification of the liquid oxygen. Teflon insulated wires powering the stirring motor caught on fire. The concentrated oxygen and flames caused the tank to explode. Better insulated wires were used in future missions. No person was found responsible, but the failure was attributed to the wire's manufacturer. The cause of this disaster is the explosion when stirring oxygen tanks. So typically they stir the oxygen tanks, to get an accurate reading of how much oxygen they have. And when they went to stir the tank to get that reading, that's when a fire happened and an explosion. 3 Mile Island. So 3 Mile Island is located in the state of Pennsylvania. Date: March 28th, 1979. What happened? Well, the 3 Mile Island nuclear generating station had a partial core meltdown. What or why failed? The plant's main feed water pumps and the secondary non-nuclear cooling system failed. Poor operator training was determined to be the leading factor in the failure at 3 Mile Island. The accident caused concerns about the possibility of radiation-induced health effects such as cancer. However, there has been no evidence of any unusual health problems in the area. The cleanup took nearly 12 years and cost approximately $973 million. Training reforms are among the most significant outcomes. Training became centered on protecting a plant's cooling capacity. The main failures with the 3 Mile Island disaster was that the water pump cooling system failed and poor operator training. We'll move on to Chernobyl next. On April 25th, 1986, in the former USSR, now known as Ukraine, a nuclear chain reaction in the reactor went out of control, creating explosions and a fireball which blew off the reactor's heavy steel and concrete lid. The lost control of the reaction was blamed on an unauthorized experiment in reactor number 4. 31 people died immediately in this explosion. Thousands more are believed to have died since then from the exposure to radioactive waste. More than 3 million of Ukraine's 50 million people were affected by this disaster. The main health concerns centered around exposure to radioactive iodine. Over 116,000 people were relocated shortly after the explosion. Now, years after the disaster, the people of Ukraine are still dealing with the radioactive byproducts. The main culprits for this engineering failure were an unauthorized experiment, a nuclear chain reaction, and that they lost control of what was going on. And the final engineering failure that we're going to look at here today is Minnesota's I-35 bridge collapse. The I-35W Mississippi River Bridge, officially known as Bridge 9340, was an 8-lane steel truss arch bridge that carried Interstate 35W across the Mississippi River in Minneapolis, Minnesota. During the evening rush hour on August 1st, 2007, it suddenly collapsed, killing 13 people and injuring 145 more. The cause is linked to a fracture in a gusset plate that played a key role in the collapse of the Interstate 35W bridge. So a fracture would be like a break. Features of the new bridge or redesign include a 100-year lifespan, 10 lanes of traffic, 5 in each direction, 2 lanes wider than the former bridge, 189 feet wide. The previous bridge was 113 feet. 13-foot wide right shoulders and 14-foot wide left shoulders. The previous bridge had no shoulders. Light rail transport ready, which may help accommodate future transportation needs. These were all part of the redesign in the new bridge that was constructed. And this wraps up our engineering failures for today. Have a great day, 6th graders. Bye.